Hello and welcome to the Mind Map about Year 7 Earth and Space Science. In this podcast, we're going to talk about the Earth, we're going to talk about important astronomers, and we're going to talk about our First Nations people and their beliefs. In this mind map, I've also included the information about the Australian curriculum that needs to be covered. Start with the Earth. The Earth is tilted at 23.5 degrees. This means that true north is not the North Pole. True north is at the top of the world, whilst the North Pole is where the magnetic field is, and they are off by 23.5 degrees. The equator separates the northern hemisphere from the southern hemisphere. The tilt also affects the day and night at the poles, in that in summer in the North Pole, it can be 24 hours daylight, and in the South Pole, it can be 24 hours of darkness. The tilt also accounts for the seasons in the hemispheres. The Earth rotates on its axis, and there's one rotation every 24 hours. The Earth also revolves around the Sun, and one revolution takes 1 year, which is 365.25 days. Given that we've got 0.25 days every 4 years, we need to have an extra day, and this creates the leap year, or the 29th of Feb every 4 years. Okay, day and night. The Earth rotates from west to east, so the Sun rises in the east and sets in the west. As the Earth rotates, different parts are exposed to the Sun. The part facing the Sun is in daytime, and the part that is away from the Sun is in nighttime. And as I said before, due to the tilt, the poles can either have 24 hours of sunlight or 24 hours of darkness. The seasons. As the Earth revolves around the Sun, the tilt creates different seasons. The hemisphere closest to the Sun is in summer, whilst the other hemisphere is in winter. When the northern hemisphere is in summer, the southern hemisphere is in winter, and vice versa. The summer solstice is the longest day of the year, and the winter solstice is the shortest day of the year. When the northern hemisphere has the southern solstice, the southern hemisphere has its winter solstice. The equinox occurs when there is equal lengths of day and night. Now we're going to talk about the phases of the moon. The moon revolves around the Earth in an elliptical orbit. Elliptical means oval, but this elliptical orbit is not equal. This creates supermoons. The moon's orbit is inclined by 5.14 degrees. The moon revolves around the Earth every 27.3 days. We call that the lunar month. The moon also rotates on its axis every 27.3 days, and we call that the lunar day. And because the lunar month equals the lunar day, we only see one side of the moon. A lot of people think that the moon emits light. It doesn't. It only reflects the light from the Sun. As the moon revolves around the Earth, our view of the reflected light changes. The change in our view of the moon is called the phases of the moon. When the moon sits perfectly between the Sun and the Earth, we can't see any light bouncing off it, and we call that the new moon. When the Earth sits perfectly between the Sun and the moon, we call that the full moon, because we can see the full moon. When our view of the moon is moving from the new moon to the full moon, it is called waxing. When our view of the moon is moving from a full moon to the new moon, it's called waning. Seeing a small slither of the moon is called a crescent. Seeing half the moon is called a quarter, and seeing most of the moon is called gibbous. And on the side here, we've got a picture of the different phases of the moon in the southern hemisphere. And you can see as we're going from the new moon to a waxing crescent to a first quarter, then to a waxing gibbous, then to the full moon, which is half the moon illuminated. Of course, the back half is not illuminated. Then we're going to a waning gibbous, a third quarter, and a waning crescent before going back to the new moon. Now let's talk about the tides. All objects with mass have gravity. Gravity pulls other objects towards the center of the larger object. The tides on Earth are affected by the gravity of the moon and the Sun. The gravitational effect of the Sun and the moon pulls on the water on the Earth, and this creates tides. A spring tide is when the Earth, the moon, and the Sun are all in a line, either the new moon or the full moon, and this creates the strongest pull on the water, creating the highest high tide. A neap tide is when the Sun and the moon are at right angles to each other, so this is the first and third quarter of the moon. These forces cancel out and it creates the lowest high tide. All right, now let's talk about eclipses. A solar eclipse is when we have the Sun, the moon, then the Earth. So the moon is in between the Sun and the Earth. The shadow of the moon falls on the Earth. So when the Earth is in the umbra, we call that the total solar eclipse. When the Earth is only in part of the umbra, we call that a partial solar eclipse. So if we're looking at the diagram here, you can see the full shadow is called the umbra and a partial shadow is called the penumbra. Right, a lunar eclipse is when the Earth is between the sun and the moon. The shadow of the Earth falls on the moon. So the moon is in the umbra, and we call this the total lunar eclipse. And when the moon is in the total lunar eclipse, we call this the blood moon. Now we're going to talk about some famous astronomers. Ptolemy was alive between 100 to 170 years CE. He developed the Ptolemaic system of the universe, where the Earth was at the center and everything was revolving around it. We also call this the geocentric model. Then Omar Khayyam, who lived between 1048 to 1131, he determined the length of a solar year very accurately. And then from that, he developed a very accurate calendar. Nicholas Copernicus, who lived 1473 to 1543, developed the heliocentric model, which means the sun is at the center of our solar system and everything else, including us, is revolving around it. And in his lifetime, the world started to pay more attention to science and less about stories, and we call this the start of the scientific revolution. Next, we have the very famous Galileo, who lived between 1564 and 1642. He improved the telescope to view both the moon and Venus. He discovered many features of the moon. He also discovered 4 of Jupiter's moons and the rings of Saturn. And because of this, he's known as the father of modern astronomy. Next, we've got Johannes Kepler, who lived between 1571 and 1630. He improved the functioning of the telescopes, and he devised 3 laws of planetary motion, which we won't go into. He also postulated about how human vision works. And then we have the first woman of note. Not that women were unimportant, but most of the time, if they were involved in science, they were working with their husbands. And Caroline Herschel lived between 1750 and 1848. She was the first woman to discover a comet officially, and then she discovered 7 other comets, including one named after her, which is 35P. She worked with her husband to catalogue many nebulae and star clusters. A nebula is the birthplace of stars, and a star cluster is where there are many stars in a very small area of space. On the side there, we have actual pictures from the works of the famous astronomers. Now we're going to talk about the beliefs of Australia's First Nations people. It's important that we recognise that the Australia's First Nations people were here 65,000 years ago, well before the 200 years that we've known about European settlement. And all knowledge was passed down through the generations by songs, dances, stories, pictures, and word of mouth. Australia's First Nations peoples have a long understanding of the environment through their deep connection with the land, and it's reflected in their seasonal calendars. There's not just one Aboriginal calendar. The different parts of Australia had different calendars, but here is the Noongar calendar of southwest Western Australia. And I might not say these names correctly. Birak is between December and January. It's noted to have hot and dry easterly winds with a southwest sea breeze. Boonaroo is between February and March. It is the hottest part of the year with no rain. Jiran is between April and May. This is where the weather starts to cool down, there is a southwest wind, and the first rains appear. Makuru is June and July. It is the coldest and wettest part of the year, what we might call winter. Jilba is August to September. It has variable temperatures and the land starts to dry out. Kambarang is October to November. It really starts to warm up. The flowers bloom and we start to get longer days. Just as our folklore has stories about creation, so do the Noongars, which are again the people that lived in the southwest of WA. Margit is the Milky Way. Margit was created by a magpie who was tired of the darkness and lifted it up with a stick to reveal the light. And he got tired of the constant darkness, and so he scattered his feathers, and these feathers became stars. The Milky Way is the pathway between Earth and the afterlife. The stars of Margit are the children waiting to be born. When a lady falls pregnant, a star enters her womb. All right, and then just to show you, we have another group of Aborigines that live in New South Wales and Queensland. And they've got slightly different beliefs. Gawage is the emu, and his friends are Daramulam and Barme. Daramulam is a spiritual being, and Barme is the creator. Gawarage appears in the sky when the emu appears on the land. And we can see here a picture on the left-hand side, what we call the dark emu. Okay, and this dark emu appears in the night sky when real living emus appear on the land. The Milky Way is a celestial canoe that Barme uses to cross the sky, and his wives and children follow, and they form the Southern Cross and the Pointers. Thank you for listening. I hope you've learned something, and goodbye.